Hello and welcome to this video where we'll go into conceptual model of business requirements. This is very important as when you're doing data modeling, it's not just creating tables and structuring it for implementation because you need something to implement, right? So it should always start with the business rules and the business requirements. It's very important that you talk to the business stakeholders and get the requirements in order to get a conceptual model which can be agreed upon. Afterwards, you take the conceptual model to build a logical model, physical model, and actual implementation. So there's a few steps in the data modeling journey, which is very important that you take in order to get it right. This is an iterative process, but it's important to be aligned with the business. Yes, so let's move on to the keynote now. So creating a conceptual model of a business requirements is the first step in data modeling. So we need to clearly understand the business. So starting with modeling in general, all models are wrong, but some are useful. George Box, he was a statistician. So this is an example. This is a railway for the railway stations in Stockholm's T-bana. So here you can see that this is a railway map. It's a model with some simplifications. For example, it's not drawn to scale. It doesn't really represent exact geographical positions. Straight lines or fixed angles are used. Remove unnecessary details. As you can see, this is a model, and this model is not perfect. It's a simplification of the reality. Then why wouldn't you draw it to scale? And why wouldn't you represent it in exact geographical positions, etc.? That is because when you do that, it becomes much harder to read. It becomes harder to understand from the user's perspective. As this simplification, I can quite simply see which the next station is, and I don't need to know exactly where it is in geography. This makes it simpler. And it's, of course, this model is wrong, but it is useful. So keep this in mind when you're doing modeling. So all the models you're making are a simplification of reality, and it will always be wrong as well, but it's also useful. So data modeling journey for transactional data. Transactional data means we have transactions. So for example, you buy something, you order something, then you insert some new data rows. So these are transactions. So we start with the business requirements. The business requirements, we can have stakeholder interviews. We identify key business processes that are worth including in the database design. And then afterwards, we go into finding the entities and relationships between the entities. So define main objects in the system and how they relate to each other. And then after we have done that, we'll create a conceptual model. So this is a high-level entity relationship diagram, ERD, where cardinality is defined, like how many of one entity is related to another entity. And then we have the logical model, so it becomes more, for each step, we have more and more details. So when we have come to after conceptual model, we go into logical model, and then we add the attributes. We add primary key, foreign keys, and we make something called normalization of the structure. So that when we normalize, we will decrease data redundancy, we have data consistency, and data integrity. So these terms will be more and more common, and you will understand them more when we go to that step. After logical modeling, we have the physical model. So the difference is that in the logical model, it's still not depending on a specific database. However, in the physical model, we will convert the logical model into database structure. So you choose the database engine and you define the data types, the constraints, etc. So the physical model is implementation ready. So you can implement it in the database that you choose, the database engine. So this is the difference. So you can see that it becomes more and more detailed. So then one question might arise is like, why do we have to do all these steps? Why do we need to do a conceptual model when we can have a physical model that already has everything in the conceptual model and the logical model? This is because it's not easy to come up with the physical model directly that will reflect the business. And also you need to, in order to correctly reflect the business, you need to have conversation with the business, right? So you have to have dialogue with the business stakeholders so that they will understand what you're doing. You have a conceptual model which is quite simplified. So then conceptual model will be easier for both the technical and the business stakeholders to understand and agree upon. And then afterwards you go into more technical, which can be implemented into the database. Is that understood? Yes. So the reason for doing conceptual modeling, we want to bridge the gap between business and technical teams. We want to help the stakeholders understand how the data is structured. We ensure business rules are correctly reflected in the database. So if we haven't done a conceptual model, we jump directly to the physical model and then we don't talk to the business stakeholders. We present it to the business stakeholders, they don't really understand it. And then there's a risk we create a database that doesn't reflect the business rules. And the downside from that is that maybe they will drive some decisions based on the data. And if this data doesn't support what they want it to reflect, then we will have a problem. Yes. And conceptual modeling is part of a foundation for business database design. So very important step here. Okay, so let's go into an example. We have this fake company, Ecream, which is working with ice cream, right? Ice cream e-commerce. And the business requirements could look like this. Customers should be able to browse and order ice cream flavors online. Each order should contain one or more ice cream flavors. The system should store order details, including order date and total price. Customers should provide their name, contact details, and delivery addresses. Each ice cream flavor should have a name, price, and availability status. Okay, so now we have these are business requirements, and we won't go into all of them. We will come back to this example when we go into the logical modeling and the physical modeling. So first, we need to identify the entities and relationships from the requirements. Entities are the objects. These are business objects. And relationships is how they relate to each other. Okay, so entity, a business object, it could be an actual physical object. For example, customer, that's a business object. However, this is physical, right? They exist. However, the order also exists, but there are some within the business, like it exists in the business, but it's not a physical object. So here, customers, it's an entity. Or customer is an entity. Note that we use singular, not plural, for the entities. And ice cream flavors, this is a product entity. So we have several ice cream flavors in the products. And here we have a statement. Customer can place one or more orders. Right? Customer can place one or more orders. Because customers should be able to browse and order ice cream flavors online. So then if you think about this, you can come up with that customer, they can place one order, but they can place several orders. And then each order should contain one or more ice cream flavors, right? So order is an entity as well. So we have customer entity, we have product entity, and we have order entity. And here, this is a relationship between customer and order. So customer can place one or more orders. Let's go more in detail with this. So a conceptual ERD for ice cream using something called the crow's foot notation. This is also called information engineering. Crow's foot is because the many side looks like a crow's foot. So here's the example. We have customer entity, order entity, and product entity. And then we have these relationships between them. So these are entities, and these are relationships. So customer places order. And you can see there are some notations here. Let me zoom in here to show you. Actually, you cannot see when I'm zooming in. Yeah, you cannot see that. So customer can place one or more orders. So customer, it can place one or more. So this crow's foot means more or many. So we have a customer can place one or more order. And when you want to read it backwards, you have an order can be placed by one and exactly one customer. So an order can be placed by one and only one customer. So this means like 2 bars here means one and only one. So you should read it as this is one, the minimum one, and then you have the maximum is one. So one and only one. While here is one or more, one or many. So you read it from right to left, you have an order can be placed by one and only one customer. Okay, so you always use the singular of the entity which you have the statement starting, for example, customer here. So customer, then you use singular, one customer can place one or more orders. So I'm repeating this several times because this is tricky in the beginning to get to understand. But when you get it, it's actually quite neat notations. And there's actually several types of notations for conceptual diagram. For example, you have UML, and you have also another is Chen's notation. But the that is most popular is the information engineering or crow's foot, which we use here. I will show you the most used one in industry. So here, an order, it contains one or more products. And a product can be contained by 0 or more orders. So this means 0 or more. So note that an order must contain at least one product, right? But it can contain several products. An order can only exist if there is one customer, right? So we cannot have several customers making the same order. Instead, an order is connected to one customer and only one customer. So this makes the order entity, it makes it into a weak entity, it's called. So it depends on the customer to exist. It cannot exist on its own. Okay, so let's move on here. So we'll break down the cardinality symbols in crow's foot notation. And here, this is 0 or 1. So if you have only 1 here, then it could be 0 or 1. And if you have here a O or a 0 and you have the crow's foot, then it's 0 or many. And if you have this one, it's 1 and only 1. And this one is 1 or many. So note these cardinality symbols because this will be useful. This is very useful. So learn this, and it's easy way to see it as I said before, like you have 1 and you don't have another here, so you have 0. So it's 0 or 1. Or you can see it as the leftmost, the one closest to the line ending is the one that is the maximum one. So you have 0 or 1. This is 0 or many. This is 1 or many. And this is 1 or 1, or 1 and only 1. Yes. So so that was the cardinalities with one entity, but now you have cardinalities you map the cardinalities between two entities because you have a relationship between two entities, right? So cardinality is how many instances of one entity that can be associated with how many instances of another entity. So for example here, you have a person has one and only one birth certificate. And a birth certificate is associated with one and only one person. So that must be a one-to-one relationship. In general, one-to-one relationships are quite rare. So you need to ask yourself, are we sure that this is a one-to-one relationship? And are we sure that both the person and the birth cert should be entities? If you're not, another example could be like person and social security number. Yes, that is unique. And maybe you think that would be a one-to-one relationship. However, the social security number is more accurate as an attribute in the person entity instead of an entity by itself because it doesn't contain other attributes, right? So this is what you need to think of. And then we have one-to-many. So here, a customer can order one or many orders. An order can be ordered by, or an order is associated with one and only one customer. So this is one-to-many because one customer can have several orders. And if you read it in the other direction, from order to customer, then it's a many-to-one relationship. And here we have many-to-many. So we have artists can sing 0 or several songs. And a song can be sung by one or more artists. For example, you have several artists singing the same song in a band, for example. Yeah, one-to-one is uncommon, and many-to-many can't be implemented directly into the database. So you need something that is called a bridge table, which we'll come back to later on. Why should we map the cardinality? This matters because this will actually affect your implementation later on. The cardinalities will decide how the actual tables will look like. If you need an extra bridge table, for example, for this many-to-many, and where to place your primary keys and foreign keys. So there's a lot of design in the database that cannot be made if the cardinality is not set. And I've already talked about this, but we have minimum and maximum cardinalities. For example, here, customer places orders. So these are the minimum cardinalities. So you have one, right? And then you have the maximum cardinalities, that is 1. And you have many here. So that's why you have customer can place 1 or more orders. An order can be placed by 1 and only 1 customer. This is a one-to-many relationship, or many-to-one if you read it in the other direction. So if you have from order to customer, then it's a many-to-one relationship. As I said before, entities, relationships, and cardinalities, they will affect the implementation of the database later on. This is a very important concept to learn and do conceptual modeling. So I encourage you to practice a lot of conceptual modeling and do it with pen and paper, whiteboard. We'll use lucid charts to show that, but it's always good practice to use pen and paper. Yes, so in this video we have gone through going into database design, into ERD and conceptual modeling from the business rules. So you start with the business rules and the business requirements, and then you take it further to identify the entities and relationships between them to use in order to make a conceptual ERD. And the conceptual ERD is a very high level one, which both the technical people and the business stakeholders can understand, and you can easier align the database design to the business requirements. This is really good to practice, and in the next videos we'll come into logical modeling and physical modeling. See you in the next videos. Bye.